Okay, a very good day to you. Today we are going to learn the genetic algorithm. So the outline for today class contains of introduction to genetic algorithm. Second, the genetic algorithm step. Third is a case study, okay, to solve the linear equations problem. Fourth is MATLAB implementation of GA toolbox. Okay, what is genetic algorithm? Genetic algorithm is a particular class of evolutionary algorithm that actually are based on genetic and natural selection, okay, such as inheritance, mutation, okay, selections and crossover. And then it's normally we use to maximize, okay, let's say the cost, okay, or minimize, okay, maximize, okay, maybe you have the maximize profit or minimize the cost. So that what we call objective function or the cost functions. Okay, why should we use genetic algorithm? Some of the advantage of a genetic algorithm include that, okay, you have the optimized with continuous or discrete variable, okay, doesn't require derivative informations, okay, as you have the in the calculus technique we need, okay, to get the derivative of your objective functions. Third is simultaneously search from a wide sampling of the cost surface, okay, deal with a large number of variables, is well suited for parallel computers, okay, and so on. I think you may read it. Okay, we have classes of search techniques. Okay, it's actually the calculus-based technique. Exactly, you have a function to be maximized or minimized. We can use direct method, okay, such as Fibonacci or Newton method. Okay, Newton method, we need to get the derivative, or indirect method to search for the maximum or the minimum, okay, of the given, okay, objective function. Okay, the GA is actually under the guided random search technique. Okay, so belong to evolutionary algorithm. Okay, it can be implement it, okay, using parallel computing or sequential computing, okay, until you get a steady state, okay, solutions. Okay, some GA application types, for example, you can use in machine learning, deep learning, okay, in designing your, okay, neural network or deep neural network, okay, to improve the classification algorithm, okay, or let's say the predictions, okay, okay, or other applications such as signal processing, game playing, okay, scheduling, robotic, and so on. Okay, the simple genetic algorithm pseudocode, okay, involve initialize the population, calculate the fitness of the population. While the stopping criteria is not satisfied, we'll select the parents, perform the crossover to produce the offspring, and then apply the mutations, calculate the fitness, and the process is looped over until the stopping criteria is satisfied. The genetic algorithm steps, okay, first step, we determine the number of chromosome, okay, generation and mutation rate and crossover rate value. Step 2, generate okay, the chromosome number of the population and initialization value of the genes, okay, chromosome with random value. And then step 3 is actually we process a step 4 to step 8. Step 4, okay, we evaluate the fitness value of the chromosome, okay, by calculating objective function. I mean, first of all, we must have the objective functions. Okay, what we want to do, we want to maximize or minimize. Okay, and then we calculate the fitness value. Okay, and then we'll choose a chromosome based on the best fitness value. Then we do the crossover mutation to produce a new chromosome of the offspring. Okay, and then we'll get the solution, which is the best chromosome. The process is repeated until the stopping criteria is met. Okay, these are this is a flow chart for the genetic algorithm. Okay, first of all, we initiate the solution. Okay, by generate the chromosomes. Then we evaluate it. Okay, evaluate use the fitness function. We evaluate the fitness function in order to select the parents based on the roller view here, and then perform the crossover mutation in order to generate the new solution. If we get the best chromosome, then it can give it the best chromosome can produce the best solution. Then the process is stop. Otherwise the process is repeated again until we get the best solution. The sample step to show how the GA is working. Let's say this is the initial population, and then we'll calculate the fitness function. I think this is objective function, and then this is a fitness function. And later on we do the parent selection, then the crossover. For example, these two chromosomes are crossover. You see the cross at the first 3 digits. So this is 48552. Go to the first one, 52411. So same thing here, 124411. After the crossover, we do the mutation. Meaning this is at the third digit. 5 is replaced by 1. Here 7 is replaced by 2. The last digit 1 here is replaced by 7. So this is what we call mutation. This is crossover. Now we'll take one case study where we want to find the value of A, B, C, D that satisfy A plus 2B plus 3C plus 4D equal to 30 using genetic algorithm. So our objective function will be, we move the 30 to left hand side. So you got x1 plus 2x. Let A, B, C, D become x1 plus x2 plus x3 plus when A is x1, B is x2, C is x3, D is x4. So the objective function become first we move the 30 to left side, so become x1 plus 2x2 plus 3 x3 plus 4x4 minus 30, and then we take the absolute value. If we don't take absolute value, when we minimize, we may have the most negative value as your minimize. So but we want to find ABCD that satisfy equal to 30. So we have to take the absolute value so that it won't get the negative. The objective function won't become would take the negative value there. And then let's say we have the restrictions. A, B, C, D are integer between 0 to 30. Step 1, initialization. Let's define the number of chromosomes in population are 6. Chromosome 1, 2, 3, 4, 5, 6. Then we generate random value of a gene A, B, C, D. A, B, C, D for 6 chromosomes. So the A, B, C, D for chromosome 1 to 6 are generated randomly. As given here. After that, step 2, we do the evaluation of the objective function. Is actually to minimize the absolute value of 12 plus 2A plus 3C plus 4D minus 30. And then we evaluate this one. I can show you how we can. Hold on, sir. So we can plug in the. You can get here ABS by shift this button, and then A, you see A, B, C, D, E, F, X, Y, M. So you need to press alpha. I get this function. A plus 2B plus 3C plus 4D minus 30. And then you calculate one by one by inputting, first of all, the A value is, A is 12. Okay, B is the second one is 5, C 23, D 8. So you get 93. So repeat for the second chromosome. Okay, calculate again. A 2, B 21, C 18, D 3. So you get 80. Okay, repeat for the third chromosome. Okay, the chromosome A is 10, B is 4, C is 13, D is 14. You get 83. Then do it for the fourth chromosome. Calculate. A is 20, B 1, C is here 10, D 6. So you get 46. Calculate for the fifth chromosome. A is 1, B here 4, C 13, D 19. So you get 94. Okay, lastly, the last chromosome. Okay, A is 20. Okay, B 5, C 17, D 1. Okay, 1. You get 55. So step 2, we evaluate the objective functions. Okay, using key in the function into a calculator. Okay, by inputting the functions and then calculate. Okay, next case we do the selection of the parents. So before that, we have to calculate the fitness probability. Okay, where the fitness probability is given by 1 divided by 1 plus, okay, the objective function from 1 to 6. Okay, remember the first 93, right? So 1 divided by 1 plus, okay, 93. So 1 divided by 94. You get this value. So repeat for, okay, until chromosome 6. Okay, see chromosome 6. 55, yeah? 55. So 1 divide 56. We check randomly the third 83. 1 divide 84. Okay. We can just randomly check the value whether correct. Okay, 1 divide 94. Mm. The setting, okay, here. Okay, and then we add up all these fitness probability. Total, we get 0.080845. Okay, when you add up, we have a total, sorry. Okay, add up, okay, all these 6K fitness probability. So you get 0.0845. Okay, next, okay, we calculate the probability of the fitness function. Okay, PI is actually fitness probability. Mean fitness, what's that? That's not the value called. Fitness probability. Now we calculate the probability of the fitness function. So P1 will be, okay, just now value in this here. 1 divide, okay. Sorry. Mean the Fi divide by total value. Fi divide by, okay, fitness probability divide by the total, okay, fitness probability. So this is okay. This is a probability. Just now, step. Okay, first of all, we repeat. First of all, we calculate objective function value. Later on, fitness probability. Okay, and then now the probability is a fitness probability divided by total value. Okay. And then C is actually cumulative probability. So C1 equal to P1. C2 is actually, okay, C2, this is actually a P1 plus P2, you get C2. This P1, P2, P3, you get C3. So you add up one more, P4, you get C4. It add up one more P5, you get C5. It add up P6, you get 1. Okay, meaning you add up all the probability value, you should get equal to 1. P1 equal to C1. P1 plus P2, you get C2. Okay, P1, 2, 3 is actually your C3. P1 to P4, sum up P1 to P4, you get your C4. P1 to P5, you get your C5. P1 to P6, you get your C6. So C6 must be equal to 1. Okay, and then we'll calculate, before we calculate, we generate random number R in the range 0 to 1 as follow. Okay, C1 is actually the 0 until, this is a C1. C2 is from the C1 to the C2 value. C3 from the C2 to the C3 value. C4 is from the C3 to C4 value. C5 is from the C4 to C5. C6 is actually C6 to C5 to C6 cumulative. So add up your, the roller, will be total, like a pie chart, is actually 1. The probability is equal to 1. Then we generate a random number for 6 chromosome here. This is a random number. Okay, and then this is still the selection process. So we'll select the new chromosome, using this rule. If the CI less than RI, R is a random number, less than CI plus 1, for example, then we'll select the new CI as CI plus 1. For example, if random number C1, if random number C1 is smaller than R1 and C2, then select chromosome 2 as a new chromosome, 1 in the new population for the next generation. For example, to select the new chromosome 1, we are going to check C1 value is actually we have 0.1254, which is less than the R1 value, which is 0.201. And then R1 value also less than C2, which is 0.2710. The condition is true. Means C1 is less than C1, which is true. R1 less than C2, which is true. Then the new C1 will be equal to the new C1 will be equal to the chromosome 2. Yeah. Then we check, we're going to assign the new chromosome 2. So we check the C2 value, which is 0.2710. And it is true less than R2 with 0.284. R2 also less than C3 with 0.4118, which is true. Hence, the new chromosome 2 will be equal to chromosome 3. Means C1 less than R1, C2, then chromosome 2. So if C2 less than R2 less than C3, then the new chromosome 2 will be equal to the chromosome 3. Now we look at to assign new chromosome 3. C3, the value is 0.4118, and it is true. It's false. Because 0.4118 is not less than the value of R3, which is equal to 0.099. R3 value, all this value, no, you got all this value. Mean C3 is not less than R3. C3 is not less than R3. So it's false. Okay, but R3 less than C1. R3, 0.099. Okay, R3, this value is less than C1. Hence, the new chromosome 3 will be equal to chromosome 1. That's right here. Okay, let's look at the new chromosome 4. So the C4 value is actually, C4 value 0.6639. Okay, check back. C4 value here, 0.6639. Okay, less than R4, 0.822. Okay, R4, 0.822. Okay, it's true. Means 0.6639 is less than 0.822 is true. Okay, however, R4 less than C5 equal to 0.7882 is false. Means R4 is not less than C5. Hence, we cannot assign C4, the new chromosome C4 4 equal to the C5. Because you see, the first part is true. Means Ci less than Ri is true, but Ri not less than Ci plus 1. Okay, but because R4 is actually, okay, what's the R4 value? Look at here. R4 is actually 0.822. R4 is not less than C5, but R4 is less than C6. Hence, the new chromosome 4 is equal to the chromosome number 6. Sorry. Chromosome number 6 here. Okay. And then we move to the new chromosome number 5. So we check C5, the value is 0.7882. Okay, is it less than the R5, which is 0.398? So also false, because 0.7882 is not less than 0.398. So this part is false. Then we check R5. Okay, R5 is actually 0.398. Okay, 0.398 actually. Okay, look at the this roller view. R5 0.398. Okay, not less than C1. Greater than C1. Greater than C2. Okay. Okay, but less than C3, right? R4 is less than C3. That's why, That's why the new chromosome for number 5 is actually chromosome number 3. Yeah. Okay, and then the last case, chromosome 6. Okay, C6 is 1. Is greater than R6. So C6 less than R6 is false. Okay. So C6 less than R6 is false. C6 less than R6 is false. Okay, and we know that R6 is actually 0.501. Check. 0.501 is actually less than C4. Hence, the new chromosome 6 is actually equal to chromosome number 4. Okay. So, if you check back, so this is actually the chromosome number 2. Mean the new chromosome 1 equal to chromosome 2. Okay. New chromosome 2 equal to chromosome 3. New chromosome 3 equal to chromosome 1. Okay, this is a new chromosome 4 equal to chromosome 6. New chromosome 5 equal to chromosome 3. New chromosome 6 equal to chromosome number 4. Okay, then after the selection of the parents, we're going to do the crossover. Okay, in this example, we use one cut point where we randomly select a position in the parent chromosome, then exchanging subchromosome. Parent chromosome which will mate is randomly selected, and the number of mate chromosome is controlled using the crossover rate parameter. Pseudocode for the crossover process is as follows. Okay, while the K less than the population, we'll do, what's B here? We will generate a random number This one maybe we skip this part because we are going to use a toolbox. Okay, move to here. We look it in manually how we do it. Okay, chromosome K will be selected as a parent. Okay, like this. Okay, we have the R1. These are actually the random number for the 6th chromosome. And then the crossover rate is 25%, so which is 0.25. So we'll select, okay, what? Chromosome K will be selected as a parent if, okay, the random number of the K less than, okay, the crossover rate. Okay, so we generate 6 random number. So we notice, okay, R1, R4, R5 are less than 0.25. So mean we are going to select chromosome 1, 4, 5, okay, 1, 4, 5 to do the the crossover. Okay, that's what they how. In the RK here, generate the random number for RK, and then if the random number of K less than the crossover rate, then we select chromosome K as parent. And then increase the K until the K until we have, for example, the example you got K equal to 6, so we iterate it until K equal to 6 in here. Okay, so in case here we choose chromosome 145 as a 145 as parent. So you see 145 to do the crossover. So 145. So they repeat again 4 5 1. Cause 1 cross with 4, 4 cross with 5, 5 loop over, cross with chromosome 1. Okay. And then after the chromosome selection, the next process is determining the position of the crossover point. Okay, this is done by generating random number between 1 to, okay, length of chromosome minus 1. We got the length of chromosome, we got actually 4, right? Just now, our chromosome, see back the chromosome. Okay, length of the chromosome is 4. So mean we'll generate, okay, random number between 1 to, okay, length of chromosome minus 1. So 1 to 3 lah. Because length of chromosome is 4. 4 minus 1 is 3. Generate, okay, a random number 1, 2, 3. Okay, let's say we get this, okay, 3 random number 1, 1, 2. 1, 1, 2. What we do? Okay, then for the first, okay, crossover, second crossover, and third crossover. Just now, remember the crossover, chromosome 1 to with 4, 4 with 5, 5 with 1 back. Okay, and okay, it got that 3 random number, 1, 1, 2, 1, 1, 2. So mean chromosome 1 will cross over at the point, okay, number 1. Yeah, this is also number 1. This at number 2. Okay, so mean the crossover point at the point, okay, up mean number 1. This number 1. So 21, 18, 03. So chromosome 4, okay, the yellow color will swap in here. So 02, 05, 17, 01. So this one in. So 2. So that's what we get. Okay, after the crossover, the result for chromosome 1 is 02, 05, 17, 01. Chromosome 4, 20, 0, okay, is 4, 13, 14. Chromosome 5, 10, 4, 18, 3. And then there's no changes for chromosome 2, 3, 6. So it's only 1, 4, 5. Okay, then how we choose, we can get here. I mean, how we okay, know which chromosome to do the crossover is actually we generate the crossover rate 25%. Then we generate 6 random number. If that random number less than the crossover rate, then we'll choose that chromosome will be selected to do the crossover. So 145. Yeah. So 145. So repeat 451. Okay. And then since we got that 3 chromosome to do the crossover, then we generate the 3 random number. So mean at chromosome 1, we'll cross over at point number 1. Chromosome 2 also number 1. Chromosome number 3, 2. We get 2 here. So this point number 1, number 2. So mean exactly the the yellow put it here. Yellow put it here. Yellow put it here. So this is a result of after the crossover. Okay, after that we'll do the mutation. Okay, to do the mutation, we need to have the mutation rate parameter. So the mutation process is done by replacing the gene at random position with a new value. The process is as follows. First, we must calculate the total length of gene in the population. Okay, we got gene in the population is 4, number of population is 6, so total gene is 24. Then the mutation process is done by generating a random integer between 1 to total gene, mean 1 to 24. If generated random number is smaller than the mutation rate variable, then mark the position of gene in chromosome. Okay, suppose we define the mutation rate 10%. It is expected that 10%, which is 0.1 of total gene in the population, will be mutated. Okay, number of mutation is actually 10%. So 0.1 times 24. We got 2 mutation. Okay, we should have 2 mutation. Okay, so that's why here we should have 2 mutation. Okay, suppose generation of random number you get 12 and 18. So you see at the chromosome 3 we got 12 and 18 here. Then the chromosome which have mutation are chromosome number 3, gene number 4, chromosome number 3, gene number 4, mean this number, chromosome number 5, we got 18 here, number 5, gene number 2. Okay, the value of mutated gene at mutation point is replaced by a random number between 0 to 30. Suppose the generated number are 2 and 5. So, position number, number 4 replaced by 2. Position number 3 here replaced by 5. Okay, you can check back. Initially, chromosome 3 was here. Okay, 12, 5, 23, 08. Check back now. Oh, we copied everything here to see. After, before and after mutation. Outside, you see. You see that. Okay, this is after the crossover. This is after the crossover. So now we're going to do the mutations. You see this one? Okay, mutation at number 3, chromosome number 3, gene number 4. Initially is 08, then replaced by 2. Chromosome number 5, gene number 2, replaced by 5. Okay, and then after the mutation process, we evaluate again the objective functions. Okay, and we compare back with the previous objective function. Okay, this value is decreased. this is increased. These two are actually increased. The rest are decreased. That's why we'll iterate it. So this is a new. After first generation, this is the new chromosome, and then the process is actually repeated for 50 generation. Lastly, we obtain the chromosome as 7531. Okay, it means that A is 7, B is 5, C is 3, D is 1. Okay, and if you put the A, B, C, D into the objective function, we get actually equal to 30. Okay, this is one simple example. Okay, and then now we are going to show using the MATLAB toolbox. We can call this Optim tools, or you can go to the apps there. Okay, when you call that in the command window, or you can directly use the optimization toolbox, and then the solver, you choose the GA, genetic algorithm, and then you let's say we would like to minimize fx equal to 100 x1 squared minus x2 squared plus 1 minus x1 squared. Okay, then you key into the function, create a function in your editor in MATLAB. Okay, let's say demo GA, input x is a vector, consists of x1, x2. Okay, x1, x2. If the ABCD, then your x consists x1, x2, x3, x4. So this is an objective function. And then put up the fitness function is a callback the function. So add that, and the function name demo underscore GA. Okay, we got two variable x1, x2. Okay, after that you click the start, then you should obtain this solution. Okay, let's show you. Let's go to the here. To call this one, you may directly using the apps. Okay, make sure you have installed the optimization toolbox. Otherwise, you cannot get this thing. Okay, continue to tools. Okay, click this one, GA. Okay, I have typed in the objective, the function y equal to demo underscore GA, this GA2, GA bracket x. So this one return the value of y. So the y function is 100 times x1 squared minus x2. Okay, all these things squared it plus 1 minus x1 power 2. Okay, and then I will put it here. This is a add demo GA. Put up X. Am I right? Check back here. Demo GA only. Okay. Okay, we got two variables, x1, x2, and just click here. If I didn't select anything because you use everything defaults, so just click start. So it's actually the objective function value is this one, 2.44, where the x1 value is negative 0.324, x2 is 0.188, 0.188. Okay, you may calculate. This is we want to minimize what's the objective function? Minimize this thing. Okay, so the minimum value that obtained from the but not same with just now. Okay, suppose we got wrong. That's a mistake. So we have 0.49. This is even smaller. What's the mistake? Clear everything. Let me clear everything. Clear all the variables. Clear all the memory first. Okay, we call the GA genetic algorithm, the fitness function, demo GA. Number of variable tools. So now this value is okay here. So you got to clear out all the memory 0.01. See, not okay. So it's okay. Now it's smaller than this value. 0.01, where the x value is 1.063, x2 is 1.122. So the rest here are actually, okay, I didn't change anything. All here are the default value. Okay, so this is using the optimization toolbox from MATLAB. Okay, and then for your practice, okay, please do your assignment, find your way out using the MATLAB toolbox to optimize, mean the same example, mean to find the value of A, B, C, D equal to 30 using the genetic algorithm in the MATLAB's optimization toolbox. Okay, so with this, okay, thank you for your attentions.